Alright, today's video is on lesson 5.6, standard form of a linear equation. And so far we've looked at two different forms of writing linear equations. Slope-intercept form, which is y equals mx plus b, and then point-slope form, which is y minus y1 equals m times x minus x1. This third form is called the standard form. And standard form is when we take both x and y and put them on the same side of the equal sign, and that's going to equal the constant, or the number that stands by itself without a variable. A and b both have to be integers. They can't be fractions and they can't be decimals. So if we look at this first example here, we have y equals 2/3 x plus 4. We want to write that in standard form. Well, it actually doesn't matter if you first get rid of the fraction or first put everything on the left side of the equation that has a variable and leave the constant on the right. I prefer to move everything first and leave my simplifying for the end, but it does not matter which way you do this. So I'm going to start by subtracting 2/3 x from both sides. Because this is positive 2/3 in the original equation, I have to take 2/3 x away. So when I do that, on the left side of the equation I have negative 2/3 x plus y equals 4. So I've rewritten this equation so that the x's and the y are both on the same side of the equal sign and the number without the variable is on the other side. So now my next step is to get rid of this fraction. Anytime I have a fraction, if I just have one fraction, it's real easy. I just multiply by the denominator. If I have more than one fraction, then I have to multiply by the least common denominator in order to get rid of both fractions completely. So in this particular problem, I'm going to multiply both sides by 3. And so when I take negative 2/3 x and I multiply it by 3, this 3 is in the denominator, this one's in the numerator, so they cancel each other out. And so I'm left with just negative 2. And then plus 3 times y, because I have to distribute this 3 to the y, and I have to distribute this 3 all the way out here to the 4, which is where I get the 12 from. So now this equation up here that started as y equals 2/3 x plus 4 in standard form is negative 2x plus 3 equals 12. Here's another example. This problem is y equals 5/2 x minus 6. So I'm going to follow what I did up here by moving this 5/2 x to the other side by subtracting it from both sides of the equal sign. So I have negative 5/2 x plus y equals negative 6. I have to get rid of this fraction, so I'm going to multiply by the denominator. So I multiply this entire thing by 2. 2 times negative 5/2 is negative 5. 2 times y is 2y. 2 times negative 6 is negative 12. So this negative 5x plus 2y equals negative 12 is a perfectly fine answer. Sometimes you will see, though, that the leading coefficient, or this very first number, is positive. And that's fine if it is. If you notice here, in order to go from this equation to this one over here on the right, all the signs of the numbers are the opposite. So here it's negative 5, here it's positive 5. Here it's plus 2y, here it's minus 2y. Here it's negative 12, here it's positive 12. So if everything's the exact opposite, that's perfectly fine. Basically what's happened is you multiply by negative 1. This entire equation by negative 1, and it changes it to this. Both of those are the exact same. All right, here's another equation. This time, it's not in slope-intercept form. That doesn't matter. I'm still going to combine my x and my y to the same side of the equal sign, which I've done here. And to do that, I add 5x to both sides. It doesn't matter that x and y are on the right now. I'm still going to multiply by the denominator, and then I'm going to get my answer of 22 equals 10x plus y. It's the same idea. Okay, here's another problem. Here it's in standard form, and I want you to write the equation that goes through this point and has this slope. So I have two options. I can use slope-intercept form, which is to find my intercept. If I have my slope, plug in y and x and my slope and solve. Then once I have b, I write it in slope-intercept form and solve as I did on the last three problems, and I get my equation. I can do the same thing using point slope form. So instead I write y minus my y coordinate equals my slope times x minus my x coordinate. Again, I'm going to solve this, and it's going to solve to be the same equation that it would be if it were slope-intercept form, which is from above. And I go through the exact same process that I did up here by subtracting 3/4 y from both sides and then multiplying the entire equation by 4. In this problem, we luck out because both denominators are 4, so we only have to multiply by 4. Here's another example that you can look at. Again, this is in standard form. Write this equation. Now in this problem, I just started by writing point slope form. I think that one's a little bit faster. And so I put those numbers in and solve. And remember, there it is in slope-intercept form. So I started with point slope, solved it down to slope-intercept. Now I have my denominator of 5 and 10. So I multiply by my least common denominator here, which is 10. And that wipes out my fractions. Here are a couple problems that you can try on your own. Have these done for class tomorrow. If you have any questions, please make a note of them. The last two questions here on vertical line and horizontal line, those, try them. Think about what the vertical line, that slope is. It's really no fun to go sledding on a perfectly vertical hill, because you're not going to remember it at the bottom of the hill. If you remember any of our conversations from class, that's not going to be fun, and it's not going to be something you'll remember because you'll be undefined at the bottom of that hill. A horizontal line is not going to be any fun to sled on either, because you're going to sit down on your sled and you're not going to go anywhere. It's going to be zero fun. So think about that for those two problems. Bring those 4 problems to class tomorrow and have a good night.